Okay, you should have a quiz for me, so I will collect that. It was the problems you were working on at the end of class, yes. Yes. Even if I checked you off, I said keep them, I'll take them next time. So I know I did go around and I have a list here of people that I checked off, but still I need everyone to turn in what they had. So go ahead and just kind of gather them up at your tables and just make sure your name's on it. Yes. You had the pink paper, right? I remember that. Make sure that after class I write something on a piece of paper and turn it in. Say I lost my homework, my dog ate my homework, or something like that. That's fine. You threw it away intentionally? No. Oh, okay. All right. All right. Let's see. Let's just kind of get them moving towards this table over here. So just all right. Yep. Okay. That'll work. Is that it? Okay. Now I will entertain some questions over homework. I believe it was page 126. Any questions over the homework from 126? Yes. Okay, good. I'm glad you asked. That was one of the ones I said was going to be a little weird, and so I think that's a great place to start. Number 27. We have 2/3 x plus 4 equals 2/3 x minus 6. All right, now if we are going to follow the steps, which I hope you are going to follow, the first thing we do is identify that it's a linear equation in one variable, right? So it is that. And now we start by trying to, what are the steps? In this one, we try and clear parentheses or fractions. We don't have parentheses, but we have fractions, right? So let's clear fractions. To do that, we look at all the denominators. And in this case, we only have 3 as our denominator. So our LCD will be 3. So my first step was to find that I have an LCD of 3. And so what I will do is I will take the entire left side of the equation, multiply it by 3, the entire right side of the equation, multiply it by 3. So my left side is 2/3 x plus 4, and then 2/3 x minus 6. Don't be hesitant to write that step in. As I've gone around and looked at not only students in this class, but in my other classes, a lot of students are trying to do that step in their head, which is fine if you're really good at this now. But if you're still trying to learn and trying to get good at it, you want to take the time to just write that step down so that you can see the multiplications that have to occur. 3 times the 2/3 x, 3 times the 4, 3 times the 2/3 x, 3 times the negative 6. So that first multiplication, what is 3 times 2/3 x? What's that? So the 3, I look at it like a 3 over 1, right? And those 3's can cancel, or you can just say multiply across 6 over 3 is 2. Either way. But that should leave you with a 2x. I'll write that down below it. What does my second multiplication through the parentheses get me? Plus 12. Now, on the other side, that 3 times 2/3 x, that's exactly what we did a second ago, isn't it? Sorry, let me put the 3 times, or 3 times 4 there. We have 3 times 2/3 x. That gave us a 2x again. And then our 3 times -6 gave us a -18. Just be careful with your signs there on that. 3 times -6, -18. Okay, so we've done the clearing of the fractions. What am I supposed to do now after I clear fractions? Combine like terms. Do we have any like terms on the left or on the right? No? Right? On the left side, can't put anything together. Right side can't put anything together. So what would I do next? Get the variables to one side. So let me see. I have variables on both sides, 2x and 2x. So we get to choose which side. So I think I'm just going to go with the left side. I'm going to try and get all my x's to the left side, which means I need to get rid of the 2x on the right. How do I get rid of a 2x on the right here? Subtract it, right? So I'm going to subtract 2x. Whatever I do to the right side, I must do the left side, right? On the right side, the 2x's cancel, and then, on the left side, the 2x's cancel also. Which means the only thing left on the left side is what? 12, right? The x's are completely gone. On the right side, -18. What the heck is that? 12 doesn't equal -18, right? Those are not the same. Not equal. I put a little slash through the equal sign. So when we run into a problem like this, if you're ever solving a linear equation in one variable, and you get to a result at the end that makes no sense, which this doesn't make sense, right? That tells you something about the original equation, that it has no solution, that there's no number we'll ever be able to figure out or find that will make the equation true. So it is possible for an equation to not have an answer. And this is kind of what happens when that case comes. What's that? Yeah, I know. That's why I highlighted those for your homework. Like, you may scratch your head on these two because I haven't shown you. Yeah. So okay, so what we will write is no solution. I will accept that on a quiz or a test if you write no solution. But there is another way that the back of the book does it. What they do is they say, they put a brace and then they put another brace and there's nothing inside of it. That represents what's called the empty set, which means that the braces mean I have a set of answers here. And guess what they are? Nothing. You see, there's nothing in those braces. So that's just a mathematical way of writing the answer is basically no answer. Got me? Okay. I don't mind you doing no solution. If you're going to move on and do more math, there's another symbol that I'll show you that you could use. It's a 0 with a line kind of at an angle slash through it. That is the same thing as the set of braces with nothing in it. It's called the empty set. Now, military people might confuse that. In the military, you what is it? I forget which one you put. I think a 0 you put a slash through. Any military people here? You put a slash through zeros in the military so you don't confuse them with O's. All right. So I think that addresses the question, right? I mean, okay. Then I think the most natural question you would have is probably on number 29 then too. I was coming in here today knowing I was going to be doing these. So 1/6, and then you have 2c minus 1 equals 1/3 c minus 1/6. Has anyone ever heard this is kind of a military thing also. When you say the number 9 in the military, like over radio or something like that, you're supposed to say niner. Anyone? You know where that comes from? It comes from the fact that during World War II, we were fighting the Germans, right? And so our pilots would be up in the air and they'd be on their radios and they'd be like, we got a, enemy at 9 o'clock, right? And then other people would be talking over the radio, and the Germans would also be using the same frequencies. And the Germans, the German word 9 means no. So if you were talking to one of your American buddies but got your communication mixed up with a German, and you hear the German say 9, you think it's 9 when he's really telling someone else no. And so it was just to distinguish the German word 9 from our number 9. Just random useless information, okay? All right, so here we go. We have a linear equation, one variable. Our variable is c, right? Now we have a set of parentheses and we have fractions. Now this is very important. When you are doing parentheses and fractions at the same time, you need to try and clear your grouping symbols first. Clear your fractions. Get rid of the parentheses before you try and do LCD. Now you can do it the other way, but it's trickier and you can get yourself into some trouble doing it that way. So we are going to remove grouping symbols first, here and here, by distributing a 1/6 through the parentheses. So I'm going to go 1/6 times 2c, and then plus 1/6 times -1. Is that okay? Those are my two multiplications. What's 1/6 times 2c? So you have to look at that 2 as a 2 over 1. So multiply straight across, you get 2 over 6, don't you? But 2 over 6 reduces to be 1/3. Is that all right? So I'm going to put 1/3 c. And you need to reduce those fractions, all right? What is the next one? 1/6 times -1. 1/6, but it's negative, right? Because you're multiplying. So -1/6. Now the other side of the equation I haven't touched. Any questions there? Does anybody see something? Like right now, do you notice something? Both sides of the equation are exactly the same, aren't they? Both sides are exactly the same. All right, well, let's still follow the steps. I'm going to now try and clear fractions. I'm going to look for an LCD. What's the least common denominator between 3 and 6? 6. So I'm kind of skipping through this because this is a homework problem, and hopefully you tried a little bit of this. I'm going to put a 6 on the left side. And then I'm going to multiply the right side by 6. Distribute through. What's 6 times 1/3 c? 6 times 1/3. 2c, right? 2c. What's 6 times -1/6? -1. See, I'm not showing that step, okay? 6 times 1/3 c, again, this is the exact same thing, isn't it? 2c minus 1. Now we would try and get our variables to one side. And the same exact thing is going to happen that happened before, right? When I try and, let's say, subtract 2c on the right and the left, the 2c's cancel, right? But this time, what am I left with? -1 equals -1. And that's true, isn't it? The last one was like two numbers that weren't equal and it didn't make sense. This makes perfect sense. -1 is -1. So what does this tell us? Well, what this means is that any C that we can think of will work. No matter what C you ever plug in, all of them will work. So in the previous example, nothing would work, right? This one, everything will work. In normal problems, usually only one thing works. Usually we only have one answer, x is 2 or x is -5. But now we've seen we can actually have nothing works or anything works. So this is the case where you get anything works. And the way that we write this is you put as your answer all real numbers. Have y'all heard that before? All real numbers. Technically, it is not correct to say all numbers. You have to have the real in there because there's things called complex numbers. And we're not talking about complex numbers, we're talking about real numbers here. So that's why we say real. We're not going to talk about complex numbers today. So all real numbers. Now, you remember I had the little set of braces with nothing in it, or I had that 0 with the slash through it? There's a way you can write all real numbers with a symbol. It's what we call a double struck R, capital R. So it's capital R, we call it double struck because the line going vertical on it, it's a double line. See that double, the double on that line? We call those double struck capital R. Double struck capital R in mathematics means all real numbers. So I'll take either one of those. The book won't do the capital R. The book will just say all real numbers. Okay? So in summary of this, there's 3 possible answers that you can get for a linear equation. You can get one answer, no solutions, or all real numbers. These are the 2 I just did today in class are not, they don't come up very often, but you need to know what to do if it does happen. Okay, the only thing we did not do last class, because we're trying to get out of this section, is we didn't work with any decimals yet. So we're going to do some problems, some examples where we have decimals. Okay, before I begin, if I have, let's say the number 3.2, that's a decimal, right? What would happen if I multiply this by 10? What happens if you multiply a decimal like 3.2 by 10? It becomes 32. It has the effect of really taking that decimal point and moving it one place over. That's all that happens if you multiply it by 10. What would happen if I take 3.2 and multiply it by 100? It would be 320. So what happens is that decimal point gets moved over once, twice. And since there's nothing past the 2, we imagine there's a 0 there. So it becomes a 320. Does that make sense? This is stuff hopefully you've seen. And what if I multiply by 1,000? It would move it 3 places over, so it would be 3200, so 3,200, 3,200. All right, so just keep that in mind that if we want to move decimals over, all we have to do is multiply it by multiples of 10. Not multiples, powers of 10. 10 or 100 or 1,000. Okay, now let's look at a problem. Let's say we have negative 6.3x plus 1.5 equals negative 4.8. Now, tell me if this is a linear equation in one variable. We have an equal sign, right? We have a variable, it's raised to the first power. We only have one variable, so it is. Does it have grouping symbols? No grouping symbols, so don't have to worry about that. Does it have fractions? No, but it has decimals, right? Fractions and decimals are kind of the same thing sometimes, so we'll just say it has decimals, all right? Now, so what I need to do is I need to figure out how I can get rid of the decimals. Notice on all 3 of those decimals in the problem that if I move the decimal place one place to the right, in all 3 of those, they become nice numbers. What I mean by nice numbers are integers. It would become 63, 15, and 48, wouldn't it? So what I'm going to do is, technically, I'm going to multiply both sides by what? To get it to move one space over. 10? But because we already know what's going to happen, you don't have to show that step. All you have to do is move each decimal, because you know whatever happens to one side is going to happen to the other. So all I'm going to do is move them. Just remember it has to happen to both sides. And I'm just going to put a little arrow here showing that what I really did was I multiplied both sides by 10 without showing the work. And I wouldn't expect you to show the work either, as long as you understand that that's what we actually did. And now this problem is pretty much ready to go, right? You would get your variable by itself, you get your constant to the other side, you'd solve for x. Agreed? Okay, I'm going to go dot, dot, dot. That means I'm not going to show the work, and I'm just going to put the answer. X is 1. That would be a good little exercise if you wanted to finish that problem off. Okay? All I want to show you right now to end this section out is just how we get it from the decimal to what we've been doing. Once we get it there, you know, you're kind of on your own with it. Okay, next example. How about okay. X plus 0.06x equals 3816. No grouping symbols, right? No grouping symbols. But I have decimals. Actually, I only have one decimal, right? There it is. Now, how many places would I need to move that decimal in order to make it a nice number? 2, right? If I take that's not what I wanted. If I take 0.06 or 0. Move it 1, 2, it becomes 6. But whatever I do to that one, I have to do to every term. So you need to look at the other 2 terms and figure out what would happen to them. All right? That's a little bit of a tricky part. Let's do the 3,816 first. What would happen to 3,816 if I move the decimal place 2 places to the right? Well, where is the decimal? Behind the 6, right? It's not there usually. We don't write it. So move it 2 places to the right. What's really back here is zeros. So that actually becomes a pretty big number, doesn't it? It becomes 381600, which is 381,600. So that number is going to get really big. And what about the x? This is the one that can be a little tricky if you miss it. Well, yes, I'm sorry. That one's going to become 6. Yes, I agree. That'll become a 6x equals, we know this is 381600. But what about the blue x on the left? What's the number in front of the x? It's a 1, isn't it? And doesn't that 1 have a decimal place behind it? So that 1, I'm going to put it on the right side here, that 1 with the decimal gets 2 places, and those are zeros in there, so it becomes a what? A 100. A lot of people miss that one because they're like, oh, there's no number in front of the x, so there's no decimal to move. There is. There's a 1 in front of the x. You have to move that decimal 2 places to the right also. So that would be a 100. X. And then plus. Do y'all see that? It's a little bit tricky. So if I were to be finishing this problem out, I would combine, on the left side, I would combine the 100x and 6x together to get 106x. And then I would be doing what to get x now? Dividing by 106 on both sides. And the answer, if you do this, is 3,600. So I'm not showing the steps there. Again, I'm just trying to get you to this point right here. Once I'm at that second line, I've moved decimals. It's what we've been doing the last 2 classes. All right, so just be careful with that, the decimals there. I still have another one to show you. Okay. How about this? 0.75 x minus 2 plus 0.25 x plus 4 equals 0.5. This is a good problem right here. I like it. This is a good exam type problem for decimal. You know what I do a lot of times to make my exams? I go back through my videos. I don't watch them all, but I'll just go and I'll just kind of like click the screen and look at the examples I did, and I'll just make a problem based on that example. I'll just kind of tweak it a little bit. So using the videos, or you all know that I post these notes, right, also on the web? I'll just print those out and look at them, and I'll just change a problem up a little bit. That's usually how I make exams. So, all right, so here's what we have. We have parentheses, and we have decimals. So I just told you a second ago which you do first. Let's see if you remember. What should I do first? Get rid of grouping symbols or decimals? Grouping symbols. I said it can be done the other way, but it's dangerous. So let's get rid of grouping symbols. That means I'm going to have to distribute a 0.75 through here, a 0.25 through here. What is 0.75 or 0.75 times x? It's 0.75 times x. Students often ask me, do I have to put the 0 in front, or can I just go 0.75? I don't care. The book does it because sometimes if it's not there, you don't see the decimal, and you think it's 75, or you know what I'm saying? Like you won't see it. So they put the 0 to kind of make you go, oh yeah, that's weird looking. Okay, it's because it's a decimal. So I'll keep putting the 0 in front. What is 0.75 times -2? So you might need a calculator here. It's going to be 1.5. So minus 1.5. You are allowed to use a calculator. All right, I don't mind you using a calculator, like I said, but don't become dependent on it for simple things like 2 minus 3. What's the next multiplication? I'm now doing the second grouping symbol over there on the right. 0.25, so 0.25 x. And then what's 4 times 0.25? 1, right? And then equals the other side, 0.5. All right, grouping symbols are all gone. Now I need to try and get rid of my decimals. So let's take a look. On that first number in front of x, how many places would I have to move that to make it a nice integer? 2. How about the second number? I would only need to move it 1, right? But the guy before, the 0.75, requires 2. That means they're all going to have to go at least 2. So I'm going to have to move it 2 on that 1.5 also. How about my third decimal? I'm going to have to move it 2. This one, I don't need to move it, but it's going to have to get moved also, right? And the last one, just once. So when you look at these, you have to look at all your decimals. You have to look at what's the most you ever need to move, and that's what you have to do to all of them. Okay, you can't do like, I'm going to move 2 on one of them and 1 on the other one I'm going to leave alone. No, it's they all get the same thing. So I'm going to go 2 decimal places, which is really saying that I'm multiplying by 100. Okay, that's what really happens here. I multiply everything by 100. So you tell me, what happens if I move it 2 decimals here on the first one there? 75x. Minus, what happens if I move that 2 decimals? 150. Remember, because there's a 0 after that 5. Plus, next one, 25x. Next one, plus 100. Good. Remember, that 1 has 2 decimal places that has to go. And then last one, 50. And at this point, we have a nice linear equation, no grouping symbols, no decimals, no fractions. You take it to town. You finish that out. You should get ... x equals 1 if you work the rest of the way. All right? All right, so what I'd like for you to do in this section for homework, and this will be all that's left for this section, page 127, you should look at 37 through 49 odd. Do you all remember the first day where I was saying that, this is the way I do my class, but I don't know how it's going to work, if y'all are going to want to stick with this? I'm kind of getting to that point where I want to get some feedback on whether or not this is working for you, if you think it's going to continue to work. So what I'd like really is if this is not working for you, you don't want to talk about it right now, just send me an email or something. I'm just trying to get some idea if I should continue this format or not. All right? Can you all do that? If you're unhappy, I mean, if you're happy, you want to send me an email, you can do that too. But I'm going to kind of say if nobody sends me an email saying I'd like to do a traditional style, then I'm just going to keep doing this. All right? Or come by my office and talk to me, whatever you want. All right. We are going to move on. We're going to go to the next section. And the next section is applications. Anytime you see the word applications, you should be thinking word problems. Applications of linear equations. And we're going to start out with this applications with just an example, okay? The idea here is that we want to be able to take a word problem or a real-life problem, convert it into a math problem, and then solve it the way we've been doing it. So every word problem I give you today is going to somehow, some way, convert into a linear equation. And then we'll be able to find an answer. All right, so the first problem is this. The sum of a number and negative 11 is negative 15. Find the number. Now, I realize that very rarely would you ever be faced with a problem like this, a word problem where they would say this. But as we move on in this section, you'll see that some of the word problems actually you might. What is that? What is that? Oh, it was an alarm. Okay. Okay. No, it's all right. Mine does the same thing. I can't. My alarms are not ever silent when I try to silent them. Okay. Sum of a number in negative 11 is, so all this problem is about is just can we turn words into math? All right, what are the key words here? Sum. Sum means what operation in math? Sum? What operation is that? Addition. So anytime we see sum, we should be thinking addition. Okay, so the sum of a number. A number. Do you know what that number is? No, it's a number. It could be any number. So that is going to be represented by what? Our variable x. Not multiplication, the variable x. The sum of a number and, let's see, negative 15. That's pretty straightforward, isn't it? Negative 15, or no, sorry, negative 11. Negative 11 is, well, negative 11, isn't it? So the sum, so I'm going to be adding some number, which I'm calling x, and some other number, which is negative 11. It says is negative 15. What is the is? Is equals. Okay, that's a big one. Is in mathematics is usually an equals. And then the other side there was negative 15, which is just the number negative 15. So what we get is this. I want to take two numbers and add them together. The two numbers are x and negative 11. So how would I write that? X plus negative 11. Now, if I'm going to do that, I need to write it this way, because we never write a plus and a minus right next to each other without a parentheses. Or I could have written what instead of that? Just x minus 11. Okay, I could have done that. Because addition of a negative number is the same as subtraction. Now, I have that. That's the sum of a number negative 11 is, so equals, right? What? Negative 15. And then this bottom one would become the same thing. So what I'm saying is you could do either one of these, top one or the bottom one. I would have probably done the bottom one. And what is that then? Looking at that, what do we call that thing there in the box? Linear equation, one variable, right? So you could solve that. How would we solve that? I mean, it's ready to roll, isn't it? Add what? Add 11 to both sides. X is negative 4. What we're saying is if you take negative 4 and you add it to negative 11, you should get negative 15, which is right. So I guess the moral of the story here is we have to somehow identify keywords and word problems, convert them into the math, and then do the math. Next one. I'm going to sit down for this. Here we go. I kind of want to make up my own here. I don't want to use the books. How about 8 less than 4 times a number is 2 less than twice the number. Find the number. All right, here we go. 8 less than. What does that mean? 8 less than. What operation do you think that's going to be in there? If I say 8 less than. Subtraction, right? The less than is subtraction. Subtraction of how much? We have to be careful here. If I say that I'm 8 less than something, then does that mean I'm subtracting the 8 from that something, or does it mean I'm taking that something and subtracting 8? Let me say it this way. Let's say I have $8 less than 40. How much do I have? 8 less than 40. 32, right? So what we did there was we subtracted 8 from the 40, right? We have to be extremely careful with this here because the same thing's happening. 8 less than 4 times a number. What's 4 times a number for us? 4x, right? So let me highlight that part. I think that's the cleanest part of that first statement there. 4 times a number, I'm going to say that's 4 times x. So that's pretty clear, I think. The 8 less than means I want to take away 8, right? I want to take away 8 because it's 8 less than. I want to take 8 away from what? 4x, right? I don't want to do 8 and take away 4x. You'll see I'm going to write them down here because that order is so important there. What's the is? Equals 2 less than twice the number. Well, 2 less than, isn't that just like the 8 less than? That meant I'm going to take away take away 2 from how much? Twice the number, which is 2x. So see if you can write down the equation real quick. See if you can do it, and then I'll write down what it is, and we'll see if they match. That's what you should have. Here's what I get on tests, and it's wrong. That would be wrong. Because look at the difference between those two. I'm going to walk up here. This first one, you're taking 8 away from 4x, right? So that's 8 less than 4x. This one, you're taking what away from what? The bottom one. You're taking 4x away from 8. Totally different. So you have to resolve that in your head, the difference between those two. And in the wording of the problem, it kind of spells it out for you. Any questions? I mean, you obviously have to practice, but any questions on this? I'm not going to solve this, okay? But you see it's a linear equation, one variable now. Next one. Twice the sum of a number and 3 is 4 times the number plus 2. This is a little tricky. Twice means what? 2 times? Twice what? The sum of a number and 3. What's a number? Number is x, okay. And 3 is obviously 3, right? And twice over here was 2, like twice 2. But how do I write that? I'm doing double twice what, though? The sum of something, right? I'm doing 2 times the sum of something. What's the sum? What are the things that I'm adding together? X and 3, right? And then I'm doing twice that. And then I'll get to the is my equals, right? So I kind of stopped here because I'll get to the other side of the equation in a second. So I'm going to write 2x plus 3. Is that twice the sum of a number and 3? No. What do I need? Parentheses. Because now that is twice the sum of a number and 3. Now my equal sign is next. What's 4 times the number plus 2? That's 4 here, 4 times. The number is x, and then plus 2 means I'm going to add 2. 4x plus 2. Now, is that right, or do I need parentheses here? What do y'all think? No parentheses or parentheses. So the reason why I'm showing you this example is because the left side of the equation needs the parentheses, the right side doesn't. And it's in the wording, and that's the subtle part of this that makes it hard. Look at, the first one says twice what? Twice a sum. So I want to double a sum, don't I? That sum needs to be in parentheses. The other side says what? 4 times what? The number. That's 4x. Then after that, plus 2. So you only want to multiply the x times 4 and then add 2. The reason, I guess the part that makes you have to use parentheses on the first is because when they say twice, twice what? Twice a sum. On the bottom one, it says 4 times. 4 times what? A number. It doesn't say 4 times the sum of a number and 2. It says 4 times the number and then plus 2. Do you see how distinctly different that is now? I mean, hopefully. It's weird. The English language is very ambiguous, right? I mean, there's different interpretations to things. So this can get a little, there's a lot of gray area here. I would distribute my 2 through and solve the rest of the way, right? Dot, dot, dot. Y'all hanging in there? I'm going to give you some time to practice some of these at the end here. Let's try what are called consecutive integer problems. Now remember, the integers, in case you don't recall, the integers, if you look at a number line, the integers are 0, 1, whoa, don't know why I did that, 2, 3, and they keep going. And then the other direction, -1, -2, -3. Those are all your integers, all right? What's not in there are like fractions like 1/2 and 3/4 and things like that. So just the counting numbers, both positive and negative, that's integers. So consecutive integer problems have something to do with these numbers. So let me draw a number line again. And let me just say that these dashes on this number line represent integers. Okay? And what if I call this integer right here x, the one right there? Then what would this next one to the right of it be? It would be x plus 1, right? Wouldn't it be 1 more than the one before it? Not 1 times it, but 1 more than it. Not double it, but 1 more than it. So this next one would be x plus 1. What would the next one be? X plus 2, 1 more than that, right? What would the next one be? X plus 3, right? And so on and so forth. I could keep going, couldn't I? What would this yellow one be to the left of x? X minus 1 would be 1 less than x. X minus 2, x minus 3. You get it? So if I tell you, hey, there's some integer, right? And then there's the integer, the next integer would be that plus 1. Agreed? Does that make sense? Those are what are called consecutive integers. They're one after the other, consecutive. So let's try a problem with this idea. I'm going to do it right below this. Here's the example. The sum of two consecutive integers is, we'll just start out something we might even be able to get mentally if we just thought about it, is 11. Find them. Well, I have the sum, right? So I'm adding up. What am I adding up? Sum I'm going to add, right? I'm adding the sum of what? Two consecutive integers. We don't know what they are, right? We don't know what they are. So one of them I could call what? X. The next consecutive one would be what? One more than that, x plus 1. Agreed? I put a comma between them. Those are my two consecutive integers. One of them is x, the other one is x plus 1. When I add those two up, I should get what? This needs to be equal to what? Is 11. Okay, let's write down this equation then. I have the first integer, which I don't know, it's called x, plus the next consecutive integer, which we said was x plus 1, right? That needs to add up to be equal to what? 11. Do y'all see that or not? You have the first integer, we don't know it, plus the next consecutive integer have to add up to be 11. So now this is a linear equation. What's x plus x on the left side? 2x plus 1 equals 11. I would subtract 1 from both sides at this point, wouldn't I? If I subtract 1, I get 2x equals 10. Notice I'm not showing that work. If I divide both sides by 2, I'd get what? 5. So x is 5. Well, that's one of the integers, right? What's the other one? Look, x was here, right? X was 5. My next consecutive integer would be what? One more than that, right? One more than that. So x plus 1 is 6. So my two integers are 5 and 6. Let's check it. If you add those up, what do you get? 11. Those are the only two consecutive integers that add up to be 11. All right, I want to do, I think, one more example. Yeah, one more example. And then I'll cut you loose to do some on your own. Half of the sum of two consecutive even integers is 40. What are they? The thing that should really stick out here is that I did not just say 2 consecutive integers. I said 2 consecutive even integers. So let's take a look at this real quick. I'm going to do, before we start this problem, I'm going to draw a number line to help you out here. Here were the integers, right? Here they are. Even numbers, 0, 2, 4, 6, right? 8, 10, forever. And negative, right? So if I were to draw a number line underneath this, and I were to come out here and mark off integers, and I call this first one that I don't even know what it is, if I call it x, and let's say that that's an even number, what's the next consecutive even integer after that? It would be this one over here, right? Now there is one here, x plus 1, but that's the one right after it, so that would be an odd number, wouldn't it? By the way, I didn't line these up. These aren't supposed to be lined up. This is just like a new integer line. The first one, if that's an even number, the next one's odd, the next one's even. So x, if x is an integer, the next consecutive even one is 2 spaces away from it, isn't it? And what would the next integer after that be, even integer after that be? X plus 4 out here. Okay? So I'm saying if you take half of the sum of 2 consecutive integers, even integers, we should get 40. Oh, you know what? Hold on. I did the math in my head wrong. Sorry. I did a product for some reason. Change that 40 in the word problem to 9. My bad. Change that to 9. All right. Shall we try this? Half. What does half mean? Going to multiply, right, by half, by 1/2. So 1/2 of what, though? What am I going to multiply 1/2 times? The sum, right? So this means I'm going to need a parentheses, doesn't it? Just like in the previous problem. The sum, so I'm going to need a parentheses. What am I summing together here? 2 consecutive even integers. How do I write 2 consecutive even integers? The first one would be x, and then I add to that the next even, which is x plus 2. I don't know what they are. Is everyone following how that worked there? So that's my 2 consecutive even integers is this right here. The half is right there. It's starting to look like just a bunch of highlighter craziness here. All right, is 9 means equals 9, right? All right, so try and write out the equation yourself. And I'll put it down here on the bottom. That's what you should get. Now I'm actually going to finish this one off. I'm going to look in the parentheses and put things together. Did anyone have a question on how I got any of that? What should my next operation be, or my next thing if I'm trying to solve this equation? Get rid of the parentheses. Good. So I would distribute through here. What's half of 2? 1. So that's just an x. What's half of 2 again? 1 equals 9. And then I subtract 1 on both sides. And x is 8. If x is 8, then what's the next consecutive even integer after that? 10. So 8 and 10 should be my answers. If you add 8 and 10 together, what do you get? If you add them. 18. If you take half of that, what do you get? 9. So it works. All right, so here's what I'm going to do is I'm going to put your homework and I'm going to put what I want you to work on in class. So this homework is page, I'm going to start you on page, where are these? 136. You're going to do, this is your homework. Your homework is 9 through 17, odd, 21, and 23. Yeah, that's good. Now what I want you to do for classwork today is same page, ten through 18 even, and then 22. See how much of that you can knock out in the next 15 minutes. And if you don't have your book with you, make sure someone else at your table does. Y'all can share. Hey, no one reminded me about the attendance. No, I remembered first. By the way, a little thing on that. If I forget within the first half hour, you have to give me at least half an hour to remember. If it's half an hour has passed in the class, then you remind me, you get bonus. All right? Because a lot of times I do remember, I'm just waiting for people to come in, that get here a little late. But attendance is going around. Okay, I will give you a grade today as a quiz grade. It will be determined on how much you get done. All right? I mean, in other words, if after 15 minutes you've only done one problem because you were sitting there just twiddling your thumbs, I'm not going to give you full credit. But if you've honestly just been working through these, I will give you full 100%. Okay, so it's just an effort grade today. Yes? Ah, okay. See, I didn't think you would do something like that. Here. There you go. All right, I'm going to turn off the recording. If you need help, please raise your hand or talk with your neighbor.